Hello, welcome to the last part of week 5 of the ECE9013 course. In this part, we are going to discuss aliasing and cloning within lists and the notion of mutability. So, to discuss these concepts, let's do that using an example. As an example, hot is an alias for the word warm. So changing one changes the other. So append has a similar side effect. As an example, let's assume A is set to be equal to 1 and then B is set to A. When we print A, we get 1. Print B, we get 1. Now assume we define the list warm to be or to contain red, yellow, and orange. And create a new variable hot equal to warm. Now if we append to the variable hot the word pink and then print out hot and warm, we would actually get the following lists. This is because hot and warm, they point to the same location. So when we're changing that location memory, both these pointers will point to that new location with the modified list. So the append operator has a side effect that we need to pay attention to. That's why if we want to make a copy of an element within a list to another location, we use that using this operator. So in this case, we actually create a new list and we copy every element in it. So for example, here we define the list cool to be blue, green, gray. Then we create another variable that makes a copy of the list cool. Now when we append the word black to this new list, and if we print the two lists chill and cool, we notice that one of them has the term black, which was appended, and the other one does not. This is because using this operator, we actually made a clone or another copy and saved that to the memory location with the pointer chill. As we mentioned earlier, one of the possible operations that we can apply to list is sort. So note the difference between sort and sorted. Sort mutates the list but does not return anything. Sorted does not mutate the list, but you must assign the result to a variable. So the sorted operator returns a sorted version of the list that needs to be assigned to a particular variable. This can be illustrated in the following example. If we have the variable warm defined as such, and then we implement the sort operator, and we try to assign it to a new variable called sorted warm. When we print them out, we print warm in a sorted manner based on the alphabetical order. But the second one, this command prints none. This is because, as we mentioned, the sort method has no return, and that's why this operation returns nothing. On the other hand, if we define another list cool and we use the sorted command, when we print cool, it returns the same original order. However, when we print sorted cool, we have the sorted version. This is because, as we mentioned, the sorted method does not mutate a list, but returns a sorted version of that list. As with before, we can have a tuple of tuples. We can do the same thing with lists. So you can have nested lists, and again, side effects are still possible after a mutation. So it's very important to pay attention to that. So now, if we implement these two blocks of command, you can try it and see that in the first case, when we print L2, L2 will be two lists, each of which will have the values 1, 2, 3, and 4, because here we're using an alias. L2 is an alias of L1, so when L1 is changing, L2 will change. However, in this scenario, because we used the colon command when creating the variable L2, we created another copy. So here in this case, when we append L1, L2 will not change. It will be two lists of values 1, 2, and 3. So it is very important to avoid mutating a list as you are iterating over it. That's why it's better if you need to change the values of a list and you want to still iterate over its elements, is to create a copy of it and iterate over the copy and then remove. And if we check for the previous example, L1 becomes 2, 3, 4 and not 3, 4. This is because Python uses an internal counter to keep track of index in the loop. So mutating changes the list length, but Python does not update the counter. So the loop never sees the element 2. So as a conclusion, the main difference between a tuple and a list is immutability. Tuples are immutable in the sense that you cannot assign a new value to the element. However, a list is immutable. So in this example, although X is defined originally as a tuple, the element that we are indexing is actually part of a list. That's why this operation works. However, in this example, the opposite applies. Although X is a list, the element that we're trying to access is a tuple, which means this operation will give us an error. The opposite here also applies. Thank you.